So this is on derivatives and integrals of power series. A derivative is still a derivative and an antiderivative is still an antiderivative. None of that has changed, okay? Now, when we talk about the radius and interval of convergence, like what we learned last time, the function, the derivative, and the antiderivative have the same radius of convergence. So they can get the same distance away from the center, but the endpoints might be different. So you just have to check the endpoints. So we're going to go through just one of these. We're going to find the interval of convergence for the function. So like the original series, the derivative, and the antiderivative. You're only going to need to do that big ratio test with the absolute value one time though. After that, you just have to check the endpoints. Do you get what I'm saying? So we're only going to have to do it once. Here we go. Limit as n goes to infinity. And on the top, you're going to have x to the n plus 1. And then over n plus 1. And then that is over the series itself. And then we're going to reciprocate it. And then we're going to look for stuff that cancels. So what is going to cancel here? Or what will we have left? That's a better way to do it. We'll have an x on the top, and then you really can't do anything with these. So x times n, and then over n plus 1. The last thing is to evaluate the limit. This is n, and this is n. When they're the same, you use coefficients, which would be x over 1, which is just x. So you just end up with absolute value of x. And the rule is it has to be smaller than 1. So your radius of convergence is 1. And that's what it's going to be for the derivative and the antiderivative as well. We won't have to do this again. We're just going to have to test the endpoints. So this is centered at where? Yeah, do you see like an x plus 3 or an x minus 7 or anything? No, so it's centered at 0. So what are the endpoints that we're going to have to check? Yeah, 1 and -1. Beautiful. Good, you guys are staying with me. All right, so let's check -1. You just take -1, plug it back in for x, and see if it works or not. So what do you think about that one? By what test? Good. I'm not writing out every step, but it would work. The terms would keep getting smaller and smaller. Limit goes to 0. Limit as n goes to infinity goes to 0. Converges by alternating series test. All right. So right here, when you evaluate the limit as n goes to infinity, n is to the first here and n is to the first here. When they're the same, you use the coefficients, which was x over 1, which is just x. And then, so like that's what we got. And the rule for ratio test is that it has to be smaller than 1. That's where it'll always be less than 1. That's kind of just what the rule is. So whatever you end up at the end will be less than 1. I just ran out of space there. Usually I write it here, but it like was going to go off the paper. All right, so plug 1 back into the original series. And you get 1 over n. And what do we think about that one? You are correct, sir. Why? NP equals 1. Good. So your interval of convergence, which I'm abbreviating IOC, interval of convergence, we want to keep the -1, but not the +1. So that's what we did last time. That was your big review of last time's lesson. Draw a big squiggly line through here. Now we're going to do the derivative. This is what today's lesson is on, is doing the derivatives and antiderivatives. So it's going to be sigma n equals 1 to infinity. And you're literally just going to take the derivative of this. That's all. You guys know how to take a derivative. It's just with x's and n's. So you would take this n, it would come down and be out front. And then the power would drop to what? Good. Do you know how if you have like an x to the 5th, you bring the 5 down and it drops to a 4? We're just doing that like in general. So you'd bring this n down. It would drop to the n minus 1. And it's over n, so what's going to happen to those n's out front? Those are going to cancel out. So you can rewrite it if you want to make it look pretty. If not, you can just leave it like that. But it's x to the n minus 1. So that's how you do a derivative. You just take a derivative. That's literally all that it is. Now we're going to find the interval of convergence for this one too. Again, you don't need to do this all over again. It's going to be the same. R is 1. We're centered at 0. R is 1. You just need to test these. It just might not come out the same for what you get to keep and what you don't get to keep. So let's test them. Let's do x equals -1. So we're looking right here at the derivative, and we're going to plug in -1. So what that is going to give you, if you were to, list out the series, 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. What do we think for that? Yeah, that's going to diverge. I don't have a reason for that. There's no like diverges because it just like, it simply doesn't work. I guess that's how I would think of it. I guess you could say it fails the alternating series test because the terms don't keep getting smaller. All right, and then for x equals +1, if you plug 1 in for x right here, you would just get 1 to the n minus 1, which would be 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. And so that also diverges. So for the derivative, your interval of convergence, you can't keep either of the endpoints. So again, the radius of convergence is the same. That was still 1. You just have to test the endpoints to see if they work or not. And then lastly, we're going to do the antiderivative. I'm going to write the original series on the board just so you can see it, so I don't have to keep like moving the paper back and forth. So how do you do an antiderivative? You add 1 to the power and then divide by that. Okay, so look up there. We're going to add 1 to the power, be x to the n plus 1, and then you divide by n plus 1, but there's still an n there. Do you guys see what I'm saying? Like that n that's still there? Okay, it's kind of like if there's a coefficient, you just keep that. All right, so that's that. We just did the antiderivative, and we're going to test our -1 and our +1. So let's see if they work. Again, you don't have to do the whole ratio test over again. You're just testing the endpoints. So if you plug in -1 for this, ooh, I did a kind of bad thing notationally. I'm hurrying because I'm trying to finish this whole lesson in the next 8 minutes, but I forgot to write something. Do you guys see it? Like, do you see something that's missing that should be there? Like when I did this, there's something that should be right here that I didn't write. Yeah, there should be a sigma there. I'm sorry. Oopsie. So what we're trying to figure out now is whether this converges or diverges. It is an alternating series because of that -1 to the n plus 1. Would this pass the alternating series test or fail? It would pass. The terms would keep getting smaller and smaller. If you did that limit as n goes to infinity, it would go to 0. terms are going to keep getting smaller and smaller. And then if you plug in 1, one to the n plus 1 is just going to be 1. Any thoughts on that one? Because we're going to have to use a different test for this one. You are right. You had a 50-50 shot of guessing though, so. We would do a comparison for this one. What could you compare it to? You could compare it to 1 over what? Good. And why does that converge? P is greater than 1. So converges by comparison. And you would have to write a whole bunch more things, but the point is it converges. Or you could say because P equals 2, which is greater than 1. And then you would have to, well, remember the comparisons. I would do a limit comparison. Remember, you had to do the limit and show that it came out to a finite positive number. It's a whole thing. But anyway, the point is it converges. So your interval of convergence for the antiderivative, you get to keep them both. The whole point and takeaway there is, do you see how all 3 of them are different? Cool. All right, go ahead and flip over 5 minutes to do these last, what is there, 3 questions on the back? I believe in us. We can do it. All right, do you see how this one's cosine? Who remembers cosine? Now it's been manipulated, but let's do cosine. Do we have it memorized? I'll give you a hint. It starts with 1.
Minus. Yes. Over 2 factorial.
Good. Fourth. Okay, good. And normally they say do the first 4 positive terms. Or I'm sorry, not positive, non-zero. They usually say do the first 4 non-zero terms, so that's what we'll go with. So that's cosine. Now what has happened to cosine? What got plugged into it? Cubed. Now we're going to do x cubed because the upper boundary is x, okay? So now we're going to do cosine x cubed. Everywhere there's an x, you're going to replace it with x to the 3rd. So that would be 1 minus x to the what? If you put an x to the 3rd in there and then square it, say 6 over 2 factorial, plus this would be x to the 12th over 4 factorial, minus x to the 18th over 6 factorial, and so on and so forth. Again, we're just doing the first 4 because that's typically what the directions say. Were we together to there? We did cosine and then we transformed it. Now we're going to do the antiderivative of that. You're just going to take an antiderivative, kind of forget all this because I know that all looks really scary. Just do an antiderivative. You're just doing an integral. What's your antiderivative of 1? X. Good. Minus. Now for the x to the 6th, it would be 1/7 x to the 7th. There just happens to be a 2 factorial in the denominator. So it will look like this. It's a 1/7 x to the 7th. There just happens to be a 2 factorial there, so you just keep it. For the x to the 12th, forget about this for a second. What should it be? X to the 13th and then 1/13. There just happens to be a 4 factorial there. So it'll look like that. Good. And then over 19. That's it. An antiderivative is still an antiderivative. A derivative is still a derivative. You're not doing anything different. That's all that is. Now here you're given f prime. What is f? To get from a derivative back to the original function, you would need to do an antiderivative. Do you notice anything about this format? Like, does this trigger anything in your head? Like, hey, you want to think of power series.
Oh, it's actually
Good. Oh my gosh, perfect. Okay, A is 1. R, this is a little tricky. It's negative x to the fourth because it's supposed to be subtracted. So it's like minus negative. All right, so let's list out the first few terms for this derivative. You would start with 1, and then you just keep multiplying by negative x to the fourth. Again, let's do the first 4 because that's usually what you get asked for. It would be minus x to the fourth. And then if you multiply by negative x to the fourth again, it would be plus x to the 8th, high, and then minus x to the 12th. So again, to get from the derivative back to the original function, you're going to do an antiderivative. So again, forget about all this because that all looks really scary. Just do an antiderivative of this. What will that give you? X minus 1/5 x to the 5th plus, x to the 9th over 9th, and then minus, yep, that's it. And do you guys get that it's plus dot, dot, dot? Like, it goes on forever. We just did the first 4. Cool, we're gonna get 1 minute. Give me this last problem, okay? Do you see how this is sine, but it's been manipulated? Okay, write out sine. Who remembers sine? I'll give you a hint, it starts with x.
Plus minus x.
X cubed over, good, plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. And to manipulate that, we're just gonna plug in 4x. So everywhere there's an x, we're just gonna plug in 4x. I'm not even gonna evaluate it because by the time I get to the end, I don't know what 4 to the 7th is anyway. 4 times 4 times 4 times 4 is 7 times. I don't know what that is. So we're just gonna write it like this. And again, I should have put plus dot, dot, dot. These go on forever. And so that's our function. What are we being asked for? What are the directions saying to do?
Derivatives.
Find the derivative. So again, forget about all this. You're just simply going to take a derivative of this. As a heads up, there's a chain rule on every single one because it's not just x, it's 4x. All right, so what's your derivative of 4x? 4. And then this would be minus. Now look, you would bring the 3 down. I'm not addressing that. You would bring the 3 down. It would be 4x to the 2nd. And then you would chain on a 4. And then over 3 factorial. I'm going to simplify that. Just, I know, give me like 1 more minute. All right, plus the next one, you would bring down the 5. It's going to drop to the 4th. You would chain on a 4. And the 5 factorial is still there. It would keep on going. I'm not going to write that last one. The only last thing I'm going to say is, do you see how there's a 3 here and then a 3 factorial? 3 factorial means this. So what's going to happen? Well, good. The 3's will cancel and this will become 2 factorial. And then the same thing will happen with this one. The 5's will cancel and it'll become what? 4 factorial. And so on.